Welcome to an overview about single-head self-attention. You may be here as you heard about transformers, ChatGPT, or AI in general. So you're at the right place. We will go through single-head self-attention step by step. I will not go into detail right now about what QKV mean. We'll cover that later. So let's start with the concept right away. Just think of the word Earth. What comes to your mind? Actually, this word or any other word can have multiple meanings, and we only know its meaning when it's embedded in the context of other words. Maybe you already guessed that our planet is meant here, but you can't be sure. It may be intended in the context of gardening, where Earth refers to soil, hence the context matters a lot. But given the sentence, our Earth is blue, it becomes clear that we are likely talking about planet Earth. So again, context matters, and only through context does a word inherit its meaning. Now, how do we do that? What's needed is information from the word itself and every other word in the sentence. Also the positions matter. We have to consider relationships. For example, Earth looks around to gather information from other words. But notice, our, is and blue are doing the exact same thing in parallel. So how does this looking around technically work? That's where QKV come in. So we have 4 words, hence we need 4 embedding vectors. Each embedding vector has a predefined and arbitrary dimension length, d here. For simplicity, we use a short length of 12 for this example. The numbers in the vector are arbitrary for presentation purposes. Each embedding is unique to the word and consists of 12 features. More features, for example 64 instead of 12, would create a richer representation. What do Q, K and V mean? They stand for query, key and value, but let's not focus on the naming too much. Understanding the concept is easier by looking directly at the calculations. We need Q, K and V weights and biases. To keep the input and output dimensions consistent, 4 rows and 12 features each, the weight matrices need to be 12 by 12. The biases are added afterward. All these parameters are initialized randomly and adjusted during training via backpropagation. Now we calculate Q, K and V. This involves matrix multiplication between the embedding matrix and the Q, K and V weights, followed by adding biases. It's important to note that the same embedding matrix is used for Q, K and V, but the learned weights and biases make the vectors different. Here's the full picture now. Matrix multiplication is performed between the embedding matrix and the weight matrices, and biases are added using broadcasting, for example in Python. If you're unfamiliar with these operations, let me know in the comments and I'll cover it in another video. In our case, Q, K and V have the same shape as the input embedding matrix because of the way the weight matrices are structured, 12 by 12. The Q, K and V vectors help enrich the initial neutral embedding vector with contextual information. For example, Earth is contextualized as planet Earth based on the words like blue and our. To calculate attention, we measure the similarity between Q and K. First we transpose K and then compute the dot product of Q and K transpose. This gives raw attention scores, which are scaled here by the square root of the dimension length 12 and normalized using the softmax function. This diagram helps visualize the attention scores. The softmax ensures that each row sums to 1, showing how much attention each word pays to others. For instance, Earth focuses significantly on blue, which provides key contextual information. These scores determine how much influence one word has on another. By multiplying the attention scores with V, we get the final contextualized embeddings. These vectors combine the original meaning of the word with context from related words. For instance, blue contributes heavily to the final representation of Earth, enriching its meaning as planet Earth. To grasp the concept, let's focus on the final embedding of Earth in the resulting vector. The second row of the attention matrix has the values 0.1, 0.1, 0.2 and 0.6. When we multiply this with the V matrix, representing the raw values of each word, we see that the V vector for blue, which is the last row of the V matrix, contributes the most to the final embedding of Earth. In contrast, the other words, our, is, contribute less, and Earth itself contributes only slightly. This demonstrates how blue updates the context of Earth, allowing us to capture its meaning as planet Earth. So, the key takeaways are: a word often has multiple meanings, and is initially represented by a word embedding vector. Without intention, this embedding would be just a rigid representation and it's lacking contextual nuance. Through the context of surrounding words, the initial embedding vector gets enriched. For example, the vector for Earth is updated significantly by the word blue, contextualizing it as planet Earth rather than gardening soil. This process is achieved using Q, K, and V, whose parameters are learned during training and applied to refine the embeddings. So that's it, and thanks for watching. Like, subscribe, and comment if you have any suggestions or want more concepts explained in detail. Feedback is highly welcome, and see you in the next video.